Hello, and welcome to my presentation on the Marcus theory and the outer sphere mechanism. What is it? The Marcus theory is a theory originally developed by Rudolf A. Marcus, which started in 1956. This was to explain the rates of electron transfer reactions, the rate at which an electron can move or jump from one chemical species, the electron donor, to another, the electron acceptor. It was originally formulated to address outer sphere electron transfer reactions, in which two chemical species change in their charge with an electron jumping, but do not undergo large structural changes. The outer sphere mechanism is a type of electron transfer which occurs between separate chemical species. Here, the two species involved in the electron transfer exists separate and intact before, during, and after the electron transfer process. Outer sphere redox reactions take place with no ligand substitutions. However, electron transfer through space require inert metal complexes and ideally ligands unable to bridge. In the outer sphere electron transfer mechanism, there is a direct transfer of electrons from the reductant to an oxidant, and the coordination sphere remains intact. However, there is a problem in the outer sphere redox reactions, as no bonds are formed or broken, only electron transfer takes place. Such issues consist of bond length change. This is due to high oxidation states mean that there is a stronger metal center which will react with ligands, so the bond lengths will get shorter. This in turn will change the bond angles. The solvation sphere also changes when going from such 2+ to a 3+ state. Here the bond lengths change, so interaction with solvent changes, as well as electron configuration changes. These take place before electron transfer. This is because these are quite a slow reaction process compared to electron transfer, which takes a very short amount of time. In the Marcus model, it examines the self-exchange reaction, the delta double dagger. The delta double dagger activation equation includes delta WG double dagger, which is the species brought together to form the encounter complex, plus delta OG double dagger, which is the bond distance change, plus delta S G double dagger, which is the solvation sphere rearrangement, plus the collision frequency contribution. On the basis of his reasoning, Rudolf Marcus developed a classical theory with the aim of calculating the polarization energy of the said non-equilibrium state. From thermodynamics, it is well known that the energy of such a state can be determined if a reversible path to that state is found. Marcus was successful in his findings, and such paths were done via two reversible charging steps for the preparation of the transition state from the precursor complex. 4 of these elements are essential for the model on which this theory is based. One is that Marcus employs a classical, purely electrostatic model. The charge may be transferred in any portion from one body to another. 2, Marcus separates the fast electron polarization and the slow atom and orientation polarization of the solvent on the grounds of the time constants differing several orders of magnitude. 3, Marcus separates the inner sphere from the outer sphere. Also, 4, in this model, Marcus confines himself to calculating the outer sphere energy with the non-equilibrium polarization of the transition state. The outer sphere energy is usually much larger than the inner sphere because of the far-reaching electrostatic forces. I hope you enjoyed. Thank you for listening.